Ms. Fung. Let's have a look at rates of change. So we've learnt a lot of things. So first of all, we started off with a curvy line and we said what happens when we want to find the average rate of change, or the average rate of change, the average gradient between 2 points. What we did was y2 minus y1 over x2 minus x1. But because we're in year 11, instead of y2, we said f of x2 or f of b minus f of a or minus f of x1 over b minus a or x2 minus x1, depending on what book we use. But it means the same thing. And then we looked at instantaneous rate of change, which is the gradient at that point rather than between 2 points. And we saw that the average always, the question always gave us a domain of 2 x values, whereas instantaneous only gave us 1 x value. And we saw positive and negative graphs, and instead of saying m, we use f dash x. And for positive graphs, we said the change is an increase in y value corresponding to an increase in x value. For negative gradient, we said the change is a decrease in the y value corresponding to an increase of an x value. What does that mean? As you go bigger in x, the y gets smaller. And for this one, as you go bigger in x, the y gets bigger. And again, we use that symbol because that's what we use for gradients now. Example 1, let y equals 16x squared minus 5. Find a change in y as x changes from 1 to 2. What is the average rate of change of y with respect to x in this interval? Now, if you are like me and get really confused when there's so many words, then it's nice to simplify this. Average rate of change means f of y2 minus y1 over x2 minus x1 pretty much. And then we're looking at the 2 points 1 and 2, so 2 there, 1 over there. Now to find f of 2, all we have to do is plug it into the equation. So let's do that. 16 2 squared minus 5, and then f of 1 would be 16 times 1 squared minus 5. Don't forget to use brackets. And then 2 minus 1 is just 1. Now simplify that. 2 squared is 4, 4 times 16 is 64, minus 5, 16 minus 5. So we have 59 minus 11, which is 48. So that's part A. Let's do part B. Find a change in y as x changes from 2 to 2 minus h. What is the average rate of change of y with respect to x in this interval? Average rate of change means this formula. So this time we have 2 minus h as our first x value and 2 as our second x value. We can see 2 minus 2 is just 0, so we have minus h at the bottom. And for the top part, don't forget to use brackets. So 2 minus h into where x is, we have 16. 2 minus h x squared minus 5. For f of 2, we have 16 2 squared minus 5 over minus h. Before we expand, we can see that the minus times minus 5 becomes plus 5, and we can just cancel that out. So there's less writing for us. Now that becomes 4 minus 4h plus h squared, and that becomes 4 times 16, which is 64. So if 16 times 4 is exactly that, so we can also cancel that out. Don't forget the minus h. And there should be a minus there. But anyway, 16 times minus 4h plus h squared. We take the h out and put the 16 in. So we have h times minus 64 plus 16h over minus h, and cancel the h's out, and the minus, multiply that in. So we have positive 64 and minus 16h. Part C, find the rate of change of y with respect to x when x equals 2. Now this is not average, so that is, we're deriving it. So derive that, so x squared becomes 2 times 16 is 32x. Now at x equals 2 means sub that in, 32 times 2 is 64. And we can see that this question is trying to make us notice that, or do you notice anything between B and C? So b is 2, and 2 minus a tiny bit because it's h. And if we made the limit of h approaches 0, we would get 64. So this is pretty much deriving by first principle, and this is deriving with the rule. But what do you need to know for the test? That whenever you see the word average, use this formula. Whenever you don't, use the rule. Example 2, the volume of a balloon leaking in air is given by the equation V equals 600 minus 10t minus 1 over 100t squared, where t is greater than 0 and V is the volume in centimeters cubed, and t is time in seconds. Find the rate of change of the balloon after 10 seconds. So the rate of change means we're just finding the derivative. So let's do that. So 16 disappeared. We have the minus 10. And bring the 2 down. It will be 2 over 100, which is 1 over 50. T squared becomes t. So that's the derivative. Now we have to plug in the 10 seconds. So t equals 10. So minus 10 over 50, or in other words, minus 10 take away a fifth. So minus 10 and a fifth. So the average rate of change of balloon after 10 seconds is minus 10 and a fifth centimeter cube per second. How long will it take for the balloon to fully deflate? Fully deflate means what? It means when V equals 0. So when does V equal 0? Well, let the whole equation equals to 0, and then we solve for t. Use the quadratic formula, it will save you time, or use a CAS if you're allowed to use a CAS. So for the quadratic formula, recall that it's minus b, so minus 10 is 10, plus or minus square root of b squared, so 10 squared is 100, plus 4ac, so 4 times a is the value in front of t squared, and c is 600, over 2ab, so 2 times 10 and 1 over 100 and 10. And then you obtain that t is equal to minus 1056.74 and t equals 56.78. And we know that time has to be positive. You have to put this statement there, t is greater than 0, therefore t must be 56.78. Another version of this question could be, for how long could this model be valid? So read the question and notice that we are always asking pretty much the same thing. If the question was asking for how long could this model be valid for, then you would say between 0 and 56.78 seconds, because that's when the volume reaches 0. Example 3, the shockwave from a nuclear blast spreads out at ground level in a circular manner. So it's a circle going bigger. Write down a relationship between the area of the ground, as a kilometer squared, over which the shockwave passes, and its radius r in kilometers. Now the area, we know the area of a circle is just pi r squared. So the rate, and then part B, find the rate of change of a with respect to r. So that would be just deriving that. So bring the 2 down, we have 2 pi r. Find the rate of change of a when the radius is 5. So this is the rate of change. Let r equals 5. We obtain, so put 5 in there, we obtain 10 pi, or in other words, 31.42. So the rate of change of a when the radius is 5 is 31.42 kilometers squared per kilometer, which is kilometers really, but it's a rate of change. So we have to write it like that. And part D, what is the rate of change of A when the area covered is 314 kilometers squared? So what is the rate of change when the area is that? So when A is that, we can see that pi r squared gives us what r is. So dividing by pi and then square rooting it. Remember, see, r has to be positive since r is greater than 0. Part D, what is the rate of change of A when the area covered is 31.4 kilometers? We can see that it says area. We know what the area is, pi r squared. So if you let that equal to pi r squared, what can you do? We can figure out what r is equal to by dividing by pi, and then square rooting it. And notice that even though it's plus or minus, we only take r equals 10 since r has to be greater than 0. Now what's the question asking you? What is the rate of change of a? So rate of change of a is this formula here, so 2 pi r when r is 10. So let's plug that in. So we have a is 2 times pi times 10, which is 62.8. So the rate of change of a when the area is 31.4 kilometers squared is 62.8 kilometers squared per kilometer. Thanks for watching, and I'll see you next time. Bye!